Introducing the Valenian PT500 Multifunctional Mechanical Fault Simulator. The system includes a 3-phase asynchronous motor, a frequency converter, coupling units, double-supported rolling bearings, a dynamic balance simulation rotor disc, a radial loading unit for the bearings, a 2-stage parallel gearbox, a planetary gearbox, a magnetic powder brake, a cooling fan, and here is the gearbox lubrication pump. On the front panel are the control and display instruments. This is the radial force display. Once you've manually applied a radial load, the force will be shown here. The system runs on standard 220 volt single phase AC power. Over here, main power switch, motor start button, oil pump switch, coarse and fine speed adjustment controls, emergency stop, a tachometer for the motor input, and a BNC terminal for motor pulse signals. You'll also find a tachometer, a BNC interface for the parallel gearbox output, a torque regulator for the magnetic powder brake, control switch for the brake, and finally, a communication interface for connecting the frequency converter to a computer. Now, let's power up the system and walk through the operation steps. First, switch on the main power. All displays should light up. Slowly rotate the coarse speed adjustment knob and the bench will begin to run. This instrument shows the motor's output speed, while the second tachometer displays the gearbox's output speed. You can also switch on the magnetic powder brake and adjust the current to control the torque output. As load increases, you'll notice the gearbox sound becomes heavier. This helps simulate the vibration and noise of gearboxes under various working conditions, such as fully loaded, unloaded, or lightly loaded. This simulator is designed to recreate a variety of mechanical faults, including coupling misalignment, rotor imbalance, foundation looseness, shaft friction, bearing faults with 5 types: inner ring, outer ring, cage, ball, and combined inner and outer ring faults, gear faults such as broken teeth, wear, missing teeth and cracks, and also faults in planetary gears, including similar issues like wear, cracks, missing teeth, and breakage. Now we'll connect the data collector and sensors to capture a vibration signal. We're using a 4-channel data collector along with vibration analysis software installed on a computer. Before we begin the test, we'll input the test item name and record the current speed and load conditions of the simulator. Once the test starts, the real-time time domain waveform appears on screen. We can open multiple windows to view all 4 channels simultaneously. When the test duration is complete, press the stop button and the data will be saved to the project directory. From there we can perform time domain and frequency domain analysis. The raw data can be exported in various formats, such as text, Excel, MATLAB, or CSV. Contact CBM Partners, your Valenian UK experts, for more information.